Welcome back to the Explainer. Okay, today we are tackling something absolutely huge. We're going to take the total chaos of a simple Git push, and we're going to transform it into a fully traceable, rock-solid deployment contract for robotics. We're officially moving away from guesswork and building a system where every single deployment is auditable, secure, and perfectly documented. Imagine this absolute nightmare scenario for a second. You've got a robot out in the field, and suddenly it starts misbehaving. Panic sets in, right? Someone inevitably asks the dreaded question, which code is running on this thing right now? If your answer is something like, well, whatever was on the main branch last Tuesday, you don't really have a release process. You just have an opinion. And in robotics, opinions do not solve incidents. A release is a strict contract, and today we're going to look at the exact mechanics of making that contract unbreakable. All right, here's our roadmap for today. We'll be walking through the release workflow, Docker tag mapping, the traceable chain, the unbreakable seal, the namespace shift, and testing what you ship. Let's dive right in.
Section 1. The release workflow. Small, but highly consequential.
So this workflow is literally the smallest one in our entire repository. It only triggers when a version tag is pushed, yet it does exactly 3 vital things using standard actions. First, it authenticates to the GitHub container registry using a standard GitHub token, which is great, no extra access tokens or rotation headaches to deal with. Second, it derives the tag set from the Git tag. And third, it builds the runner stage and pushes the image. Now, do you notice what's missing here? Tests. There are absolutely no tests running in this workflow. Why? Because they already ran on the PR and on the main branch. We completely trust the merge queue's prior work. And because we rely on the builder stage cache, this entire release build stays under 2 minutes. It's incredibly efficient.
Moving to Section 2. Docker tag mapping. 1 tag, 4 labels.
That single workflow we just talked about brilliantly translates one simple Git tag into a really robust set of identifiers. One single action, the Docker metadata action, turns one Git tag into 4 distinct image tags, and every published image carries all of them. You get a specific patch version like 0.1.2, you get a rolling minor track like 0.1, you get a latest tag for the newest push, and finally, you get a short commit SHA. This setup satisfies pretty much every possible deployment tracking need from just one single push.
Here's the absolutely crucial takeaway. When you're doing an incident review on a robot, the SHA tag is what you actually reach for. A semantic versioning tag is great for marketing and broad release tracking, sure, but when a robot goes rogue, you need the exact commit. You need that SHA. The beauty here is that both tags are on the image, and both point to the exact same digest, giving you the absolute best of both worlds.
Okay, Section 3, the traceable chain, unbreakable custody.
A release isn't just a version number. It's an unbreakable chain. Let's actually define what an audit trail means, especially in strict certification environments. Think medical, automotive, or aerospace robotics. An audit trail is a bidirectional chain of verifiable references. If an auditor comes knocking, they don't want to hear, well, we think it was this commit. No way. They want a chain they can rewalk themselves. Every single link has to be a hard lookup, not a guess, with crystal clear signatures at every single hop.
And here is how we prove this system's absolute integrity. We can trace this chain backward, step by step. You start with a Docker inspect to get the exact digest on the robot. From there, git rev parse gives you the exact commit from the tag. Then, you use the GitHub CLI to view the pull request attached to that commit. And finally, that PR body links directly back to the originating issue. It's totally bidirectional. You can go from the issue all the way to the deploy digest, or from the robot back to the issue. That bidirectionality is what makes it a true audit trail, and not just some breadcrumb trail you hope you can follow.
Section 4, the unbreakable seal. Tags are history.
Now, building this system definitely came with some painful lessons. Imagine this. You're cutting your very first release, version 0.1.0. You push the tag, the release workflow runs perfectly, but then the Docker build breaks. Turns out, a dependency is missing in the copy step. So now, you're stuck. You've got a public tag, a bright red failed build, and no Docker image on the registry. I bet your first instinct is probably to just delete the tag, fix the code, and repush it, right?
Well, GitHub rightfully rejected that attempt to rewrite history. And honestly, it brilliantly illustrates a vital lesson. A tag that has been pushed to a remote server is published history. Someone out there might have already fetched it or even built against it. So you don't rewrite history. You leave that broken v0.1.0 empty in the Git history, and you cut v0.1.1 instead. A tag is a seal. You never break the seal. You just stamp a new one.
To document those kinds of honest failures, you need really strict changelog discipline. Our changelog is a curated, human-written document where every single release entry explicitly references its PRs. If a PR isn't in the changelog, it simply didn't ship. We even added a tiny 5-line YAML check in the release workflow that scans the changelog for the new version string before it even allows the push. It blocks the tag entirely if it's missing, which has literally saved the project from undocumented ships.
Section 5. The namespace shift. Handling org transfers.
Let's talk about real-world curveballs and how gracefully this strict system handles them. When transferring a repository to a brand new organization, you would fully expect release workflows to break left and right, but ours didn't. By using this dynamic variable, github.repository, everywhere the image was named, the release workflow miraculously adapted to the new owner. It just repointed itself at runtime with absolutely zero code changes. Talk about a lifesaver.
Look at how this namespace shift actually played out in the registry. Because packages don't transfer with a repo. Version 0.1.1 stayed in the personal namespace, while version 0.1.2 automatically published to the new org namespace. Version 0.1.1 wasn't deleted, it was just inherited from the pre-transfer world. And because we documented all of this clearly in the changelog, nobody had to panic looking for a missing image.
Finally, Section 6. Test what you ship, aligning environments.
This principle is all about the critical alignment between your testing environment and your final deployed artifact. Our Docker file uses a multi-stage build. The CI environment and the release builder stage both use ROS base because they need to compile code from source on every single run. But the release runner, which is the image that actually ships to the robot, only needs ROS core. The install layout is already built, so we deliberately ship a much smaller, highly streamlined image.
But here's the catch. While the base layers differ slightly to save space, the critical dependencies simply cannot. You absolutely must pin your dependencies, like the Mujiko simulator at version 3.3.7, across all CI stages and both release Dockerfile stages. If your test environment and your shipping environment drift from one another, your test results are basically just fiction at that point. Pinning dependencies guarantees that a green checkmark in CI actually means the robot is going to work in the real world.
So, we've successfully closed the loop from code to deployable artifact. But I want to leave you with this thought to chew on. Does your current release artifact give you true confidence, or is it just a version number? A traceable image is incredibly powerful, but the process of getting there is where the real learning happens. In our next explainer, we're going to dive into the lessons learned, the integration pain that nearly derailed everything, and the one workflow we would delete on day one if we had to start over. Until then, keep your dependencies pinned and your audit trails unbroken.